Now that we have graphed quadratic functions in all three forms, vertex form, intercept form, and standard form, we're going to talk about how we can use our graphing calculator to take this to the next level. So what we're going to do is look at this problem here. We have a water balloon that is launched from a dorm room window. Its height in feet after t seconds is given by this equation. Now, normally you look at that equation and that you realize quickly that your numbers will get very large. If we tried to find our axis of symmetry and then find the y-coordinate of our vertex, we're going to get some large numbers. Large numbers are not necessarily a bad thing. So let's go ahead and graph this. So we're going to turn on our calculators. And we're going to hit y equals, which is the upper left corner. And we're going to put that function h of t in this spot here. Now, instead of t, we're going to put the variable x. That's just how the calculator responds to it. And we're going to make a table first. So to do that, we're going to press the second button and graph. And you can go up and down on this table to see the y values. So we have our x values in the first column and the y values in the second. So let's go ahead and fill in these values. So we have 128, then we had 176, then we had 192, then back down to 176, then 128, then I think we went down to 48, and then negative 64. Now, why did we stop after 6 seconds? Well, look at the height. We should do t and h of t. The height after 6 seconds is negative 64 feet. If you think about that, that means we are 64 feet below ground. And that doesn't make sense. The rocket or the water balloon is launched, and then it lands on the ground and it bursts. So why does it stop after 6 seconds? Because the height is negative. So this is an issue that occurs when we look at problems in context. You have to think about, what does this really mean? That's why we don't have any negative t values in our table, because we don't have negative time. It wouldn't make sense to say, oh, 1 second before I launched the balloon, it was at 48 feet in the air. That just doesn't make logical sense. So you got to be careful when looking at these problems that have context in it. Now let's go and look at the graph of this. So let's press graph now. And normally we just have a 10 by 10 window, meaning we have 10 units going in the negative x direction, 10 units going in the positive x direction, 10 units going in the negative y direction, and 10 units going in the positive y direction. So this is what we call our standard window for our graphing calculator. And it's just a good idea to always look at this first before deciding what to change your window to. We want to change our window because you can clearly see that we don't see a lot of the graph. Our graph goes up, and then we see it coming down. So we want to adjust our window, and there's some strategies you want to use to adjust your window. In this problem, we are not concerned with negative x values. So down here, we can say our x minimum. So right now, our window for x is negative 10, 10. Our x scale is 1. And what that means is, what is each one of these tick marks worth? It's worth 1 unit. You know how sometimes we have graphs and we have a tick mark, we're going up by 2s or going up by 5s or 10s. Right now, we're going up by 1s. So let's change this a little bit. We want our new x min to be 0. our x maximum, we know we don't need to go past 6 from this table up here. Or you could look at your graph and say, well, here's my last x-intercept. I can stop there. And let's leave the x scale at 1. Now the y minimum, we aren't really concerned about y values below the y-axis because that's underground. So let's make our y min 0, our y max. If we look at our table, we see the biggest y value is 192. I always like to go a little bit higher than that in case this is not it. We think that's the vertex, but what if there's something else going on that we aren't aware of? So let's make the y max 250. And then look what happens if we leave the y scale as 1. So I'm going to change all of these to what we had, or what we wrote down. So 0. Most people don't want to change the scaling, the x scale or y scale. But you see over here, it's trying to fit 250 tick marks here on the side. And they get very close together and it's hard to see. There's nothing wrong with it. I just don't personally like it. So what I like to do is if our y max is 250, I like to make my scale 25 or 1/10 of my max. So you see on the left now, things are much easier to see. Like I said, it just makes it look neater, in my opinion. It doesn't change anything. So I changed mine to 25. So letter D says, what is the height of the dorm room window and how do you know this? We know the height is going to be our y-intercept. That's where the balloon started. It started 128 feet in the air. When time is 0, that means nothing has happened. Nothing has passed. And if our height's already 128 feet, that means that must be where it started or the height of the dorm window. So 128 feet. And how do we know this? 0, 128 is the y-intercept. Now, to find the minimum or maximum with our calculator, here are the steps to do it, and I'm going to walk through it. You may look at this table and say, well, the vertex is clearly 2, 192. But what if it's not as clear from this table? You'll need to go and do this process down here. So in the calculator, we're going to press second trace. And you see you have value, 0, minimum, maximum, intersect, and some stuff we use for calculus. This problem has a maximum, so we want to go down to max. And where it says left bound, we want to be to the left of what appears to be the maximum. You do not need to be exact. We know our maximum is somewhere around where the cursor is, so I'm going to go to the left. And I think we can all agree that my cursor is now to the left of my max. Here's my max right about here. And that flashy thing is on the left side of that. Now it says right bound. I'm going to go to the right of that. Again, we can clearly see we are now on the right side of the max. Press enter. And it's going to say, do you want us to guess where the max is? Yes. You see it says 1.9999994. You can safely round that to 2. And the y value is 192. So we can safely say, based on our calculator, that our vertex is indeed 2, 192. So the max height is 192 feet. And when does it reach that? After 2 seconds. If you've never used a graphing calculator like this before, it's going to take some practice to remember where all the buttons are. So make sure you have this video bookmarked so you can go back and refer to it. Now here it says, what is the height of the balloon when it hits the ground? Well, think about it. If the balloon hits the ground, the height should be 0 because the balloon is on the ground. So the height is 0 feet. Now, the more difficult question is down here. When? So how much time has passed before the balloon has hit the ground? And if you look at the graph again, you can see that the balloon hits the ground, maybe around, okay, after 5 seconds, we're at 48, but then after 6 seconds, we're at negative 64. So in between 5 and 6 seconds, but we can find out the exact moment by going back to our calculation screen. So press second, trace, and we want to find the 0 or the x-intercept. We go down to 0, press enter, and we want to move our calculator to the left of it. So again, left, and notice the y value is positive because we're above the x-axis. Press enter. Then we want to move it to the right of the 0. And I know it's off our screen, but look at the y values. We're at negative 24.77. That means that our cursor is below the y-axis, so we have moved to the other side. Press enter, enter again, and this is our x-intercept, 5.46. So we would say x equals 5.46 seconds. Now we can also figure out when the balloon was 150 feet in the air. If we go back here, you might be able to guess, like say, okay, what about 4 seconds? 128, what about 3 seconds? 176, so it's got to be in between there. What we can do is go to y equals, and then in y2, type in 150, because that's what we're trying to figure out. When does the balloon reach a height of 150 feet? And you see we have 2 intersection points. So second, trace, we want to go down to intersect, the 5th one, and we want to move our cursor closer to the intersection points. Okay, it's about there. It doesn't have to be exact. So we hit enter, enter again, and enter for the 3rd time, and we get 3.62. So 3.62 seconds, because we're talking about x values. So we need seconds, up here, t is in seconds. You might have noticed that there's a second intersection point. So that means we need to find that second intersection point. So we're going to take our cursor and move over to that second intersection point. And once we get closer, we might be close enough now, but I always say, well, let's make sure we're really close. If you're not close, then it might find the wrong intersection point. So we're a little bit away, obviously, but it should still work. So you see 0.379, so we would round that up to 0.38 seconds. 0.38 seconds. So that's a way to use your graphing calculator to answer some of these questions when the numbers are not so nice and not so easy to work with. The next thing we're going to talk about is revenue or some other word problems. Your revenue, when you're selling something, like as part of a business, is going to be the number of sales, so how many things you sell, by the sale price. And that should make sense. If I'm selling cookies for $2 each, and I sell 5 cookies, okay, 5 times 2 is $10. So that shouldn't be too much of a stretch. Now, when we talk about real life situations, things are a bit more complicated. If something is inexpensive, you tend to sell more of it. And when things are more expensive, you seem to sell less of it. And there's usually a sweet spot in the middle for that. Because if you sell a lot of items for very little money, you're not making enough profit. But if you're charging too much, then you're making fewer sales, and again, not making enough profit or enough revenue. So we're going to look at these together. When we look at an equation, your R of x is going to be your revenue, and your x value is going to be your number of price changes. Because each of these problems below is going to have a different change in price. So with a graphing calculator, we're going to answer these questions. So this problem down here says a video store sells about 150 DVDs a week at a price of $20 each. The owner estimates that for each $1 decrease in price, about 25 more DVDs will be sold each week. How can the owner maximize the weekly revenue? Because if the owner sells the DVDs for $1 or $2, they're going to sell a lot more DVDs, but then the revenue won't be as high. So there's got to be that maximum, that sweet spot. So we're going to have R of x equals, well, the number of sales. We sell 150 DVDs a week, but every time the price changes, we will sell 25 more. So we're going to say plus 25x. If you think about it non-math related, just logically, if the price goes down by $2, we should sell 50 more DVDs because every $1 means 25 more DVDs. So if the price goes down by $2, we should sell 200 DVDs total because we start with 150. So that can help you with getting the first equation. The first part, the number of sales. Then the second part is going to be 20, because that's how much each DVD costs. 20 minus 1x, because the price is going down by $1. That's why it's 1x. Now, yes, mathematically, you don't have to write the number 1. I just did because I want you to see how that $1 decrease plays into this equation. So how can the owner maximize their revenue? We have to find the maximum. Well, I know that you guys could find the maximum here. This is an intercept form. But now that we have our tools, our graphing calculator tools, let's look at that. Okay, so our first equation is going to be, not the first equation, the first intercept is going to be parentheses 150 plus 25x. And the second parenthesis is going to be 20 minus 1x. And again, you might have to adjust your window. I'm looking at here, and I don't see anything. So what if we just adjusted our window to negative 20, positive 20, to negative 500, and positive 500. Now, I have no idea if this is going to be too big, too small. I'm just picking big numbers so we can see things. Okay, we see the graph going up, and over here, it's coming back down. So we know the x-intercept has to be somewhere in there. Or sorry, not the x-intercept, the maximum has to be somewhere between there. So let's change our y max to maybe 3,000. Okay, let's see if that... Okay, it's still not large enough. We want to see the maximum. Let's try 6,000. Okay, now you can see the maximum there, and we can calculate the maximum. So we're going to move our cursor to the left and right side like we did before. Now, your window does not need to be exactly like mine. Just make sure your window can see the maximum. So we have 6.99999 or close to 7. And then the Y value is 4,225. So the owner can maximize the revenue by decreasing the price by $7. Okay. Or you could say by decreasing the price to 13 because you're starting at 20. So $13 per DVD. That is what you'd want to do. On the next page, we got a couple problems here to look at. I will do this one. I'll set it up for you guys and then have you calculate it using the graphing calculator. And then I'm going to have you do this solo one. So let's set this one up first. It says a go-kart track has 380 racers per week and charges $35 to race. The owner estimates that there will be 20 more racers per week for every $1 reduction in the price per racer. How can the owner of the go-kart track maximize the weekly revenue? So R of X equals, our first set of parentheses is going to do with the sales, so 380 plus 20x for every dollar that you decrease. The second set of parentheses will talk about the price. So it's $35 minus 1x, because every time we lose $1, 20 more riders will be added to the number of sales. So that's why it's 35 minus 1x. It's $1 reduction. So now go ahead and graph this in your calculator and find the maximum. And then also do this problem too. And once you're done with that, unpause the video and check what you get. All right, so these are the answers here. So the pair one up here, I should have gotten x equals 8, so that means we wanted to decrease the price by 8. Now, the solo one here, let's talk about this a bit, because your math says at x equals -3, so why did I say we should decrease the price by 1.5 or $1.50? Remember, right here, it says for every 50% increase in rental. So that's why this is plus 0.5x, because I'm increasing by 50 cents each time I go up in the x direction, and I lose 2 sales. So when I graphed this and I found the maximum, I got x equals -3. Well, that means we should be charging less than the $12. What that tells us is that 12 is too much. Charging $12 is too much. I'm losing revenue, and I need to go backwards and charge less than that. So that's why we got decrease the price by $1.5 or $1.50. So I know the graphing calculator might be new, so you may need to bookmark this video. Like I said, watch it again just so you can see the steps on how to calculate all this stuff with your graphing calculator. So thank you for watching. Make sure to like this video and subscribe.